Okay, let's have a look at question 4. This is a variable acceleration question because r is in terms of t. Okay, let's have a look. At time t seconds, t is more than or equal to 1. The position vector of a particle p is r meters, where I is equal to c t to the power half I minus 3/8 t squared j, and c is a constant. So when t equal to 4, the bearing of p from O is 135 degrees, and they want us to show that c is equal to 3. Okay, so the bearing of P from O is 135. So they're talking about the position, so where P is. So if they're talking about the position, we just have to use the position vector straight away. So first step, we just let T is equal to 4, and then we substitute in. So R is equal to C times by 4 to the power 1/2 I minus 3/8 times by 4 squared J. So put in the calculator, 4 to the power half is equal to 2. So that would be 2ci, and then minus 3/8 times by 16 should be 6. So 2ci minus 6j is the position of the particle at t equal to 4 seconds. Yeah. And then they tell us at that instant, the bearing of P from O is 135. So if it's from O, we use the northern line of O, and then go clockwise 135 degrees. So this is somewhere around 90, this is 180, so 135 somewhere between them. So this will be 135 degrees. So P has to be somewhere along that line. So therefore, if we resolve it into one horizontal, one vertical, then we know because this is 90 degrees, and then the bearing is 135. So the big angle is 135. That means the small angle here has to be 135 minus 90, which is 45 degrees. So P is here. And then we know the I component is 2c. That means the horizontal is 2c. And then -6 is the J component. That means downwards has to be 6 down. Yeah, because 2ci minus 6j, just 2c across and then 6 down. So it has to be 2c for the horizontal length and then c for the vertical length. And then we know the angle is 45 degrees. So we can just use tan 45 is equal to, opposite is 6, because that's the opposite, and then over adjacent to c. And then tan 45 is equal to 1. So 1 is equal to 6 over 2c. So 2c is equal to 6. So c is equal to 3. That's what they have to show. And then part B, find the speed of P when t equal to 4. So speed is the magnitude of velocity. So we need to find the velocity vector. So we know r is equal to, let me just use a column vector. It's easier to see. So 3t to the power 1/2, and then minus 3/8t squared. And if we differentiate position vector, then we get the velocity vector. So bring down the power, 3 times half is 3/2, and then minus 1, so half minus 1 is -1/2. And then for -3/8, bring down the power times by 2, -3/4, and then minus 1 the power, 2 minus 1 is just 1. So that would be the velocity vector. And then when t equal to 4, we just let t equal to 4. So t equal to 4, substitute in, the velocity is equal to 3/2 times by 4 to the power -1/2, and -3/4 times by 4. So that is equal to, so 3/2 times by 4 to the power -1/2, then that would be 3/4 for the I component, and -3/4 times 4 just -3. So that will be the velocity vector, but they're looking for the speed. So the speed is the magnitude of the velocity. So that'll be square root of 3/4 square plus -3 square. Then the answer is equal to, so 3/4 square plus -3 square, -3 square, that'll be 3 √17/4. And if we change that into decimal, that would be 3.09. That would be the answer. And then part C. So when t equal to capital T seconds, P is accelerating in the direction of -I minus 27j. So be careful, the phrase they use. They didn't say moving in the direction, they say accelerating in the direction. So if accelerating in the direction of negative I minus 27j, so we only need to use the acceleration vector. Yeah, because it's not moving in the direction, it's accelerating in the direction. So we only need to use the acceleration vector. So we already know the velocity vector from here. And then to work out the acceleration vector, we just have to differentiate again. So A is just equal to, so bring down the power 3 over 2 times by negative 1/2 is negative 3 over 4. And then minus 1, negative half minus 1 is negative 3 over 2. That'll be the I component. And then negative 3 over 4t differentiate is just negative 3 over 4 because t differentiate become 1. Yeah. And then the acceleration vector is in the same direction of negative I minus 27j. So that means the acceleration vector is parallel to negative 1 and then negative 27. So to set up the equation, same as always, just like before, because those two vectors are parallel, that means the scale factor between each component should be the same because they are parallel to each other. So we just have to use the I component divided by the I component equal to j component divided by the j component. And then we just have to solve that equation to get the final answer. So first negative over negative, negative over negative, it all cancels out. And then we can divide by 3/4 for both sides. And then it just left with 1. So we have t, the part negative 3 over 2 equal to 1 over 27. So then the negative means the reciprocal. So t to the power 3 over 2 is just equal to 27 if we take the power of negative 1 for both sides. So then t should be equal to 27 to the power 2 over 3. And if we put that in the calculator, it's just equal to 9. Then that will be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.